Hello and welcome. Thank you for tuning in today. We are going to take you through our digital twin accelerator on Databricks using building operations as the demonstration use case. We will see how we unify operational data across platforms to provide real-time intelligence like observability and predictive maintenance. We are a 100% Canadian Databricks only company with over 60 engineers onshore in Canada and offices in Toronto and Montreal. We have demonstrated over 3 years of expertise in delivering high impact data solutions across all departments. We are proud to be among the top 5 Databricks certificate holders in Canada with over 90 certifications and 20 plus professional level certifications as well. At its core, a digital twin is a digital replica of a real world physical product or system. It continuously reflects the state, behavior, and processes of that system using live and historical data. A digital twin stays in sync with reality, which means as the physical system changes, the digital twin updates. And this gives us a living, evolving model of operations. The first major purpose of a digital twin is full observability. It allows us to see what's happening across the system in real time and support maintenance before issues escalate. And the second purpose is simulation and decision support. Because the twin mirrors the real system, we can safely test scenarios like what happens if demand spikes or if conditions change without impacting live operations. So, what exactly is this accelerator? It's a Databricks native solution designed to create a live, unified view of operations across complex environments while ensuring governance, scalability, and explainability. We built it to handle large, dynamic operational datasets where visibility and predictive insight are real challenges. And the goal here is simple. It is to provide a single trusted digital twin that reflects the state of all assets, processes, and interactions in your environment. Our accelerator begins by ingesting raw data from building management systems, and it continuously refines the data as it flows across the layers of the Medallion architecture. In the silver layer, we unify operational data across all systems and curate clean, standard, and governed data. And end products like dashboards and temperature conditioning tools are powered by the data that flows from our silver to our gold. And the whole Medallion architecture is governed under Unity Catalog, where all your data is governed and resides. And under the hood in the silver layer, we build a graph model where our nodes represent the operational entities. And in this case, for building ops, that is buildings, floors, hallways, elevators, rooms, and equipment such as thermostats. And the edges between them capture relationships such as building contains floors, floor contains hallways, hallway contains room, a room has a thermostat, and such relationships. And by modeling these connections explicitly, the digital twin captures not only individual assets, but also their interactions and dependencies. Importantly, this modeling is all done behind the scenes. That means our pipeline builds and maintains this graph automatically as new data arrives, providing a dynamic operational view of the building. A dashboard with observable analytical views of all the assets managed in the building. Over here, you can see all the distributions by thermostat location type or room types, by their availability status, by their vendors, and also advanced analytics such as unavailability percentage. Moving on to the second view, we are able to visualize booking trends and temperature trends. And by observing booking trends, we are able to allocate resources as required for efficient operation. For example, over here, we see a spike in room usage around the start of the year, maybe because families are meeting often. And this allows the maintenance teams to set up resources as necessary. And by observing temperature trends, if we filter by building, we are able to see a consecutive fluctuation of temperatures from 18 degrees to 22 degrees within just a period of 2 hours. And this here is a room for saving energy costs and in consequence, saving maintenance costs as well. And this graph here is also another visualization of the building and all the relationships between them. And over here, we are able to trace back all the rooms affected if the elevators don't function at floor F3. And this allows us to alert the appropriate maintenance teams as quickly as possible. And now that we've seen the dashboard, let's move on to the pipeline that populates it. The entire accelerator is packaged as a Databricks asset bundle. And this means that all the notebooks, pipelines, and jobs required to run the building operations digital twin is included within this bundle. And by bundling everything together, we ensure reproducibility and consistency across all environments, allowing the same solution to be deployed in testing, development, and production environments. And on the jobs and pipelines view, we are able to see that all our entities are parameterized as required. Any cluster information, usage policy tags to maintain observability and track costs, as well as permissions controlled. Deployment of this job is automated through standard CI/CD workflows using GitHub Actions, and changes to pipelines or models are version controlled, automatically deployed, and immediately reflected in the digital twin. So whenever changes like uploading a data contract or modifying a pipeline are pushed to the repository, the workflow automatically runs end to end. And this ensures lineage tracking of code and reliable and consistent production releases. And once this deployment is complete, the digital twin is ready to run with all the dashboards, operational views, and any such temperature conditioning tools updated as necessary. And that brings us to the end of today's demo. We have seen how we achieve real-time operational observability by modeling governed data in Unity Catalog. And with the solution, it is reusable across complex operational environments such as real estate, manufacturing, energy, and healthcare, and really anywhere where there is smart infrastructure. And it is fully configurable solution that is deployed, governed, and maintained end-to-end on Databricks using data engineering best practices to save time and maintenance costs. We hope you enjoyed learning about our digital twin accelerator for building operations solution. Thank you for tuning in.